Good morning, teachers, parents, and learners. Welcome back to our Valenzuela Facebook Live in Mathematics 7. We are now in quarter 2, week 3. Before we start, make sure that you have your learning packet, notebook, and ballpen for some information that you have to write down. For today's lesson, we will discuss translating English phrases to mathematical phrases and English sentences to mathematical sentences and vice versa. For lesson 4, we will discuss algebraic expressions and polynomials. And for lesson 5, we will have evaluating algebraic expressions. For this lesson, you should be able to translate English phrases to mathematical phrases and English sentences to mathematical sentences and vice versa. Illustrate and differentiate related terms in algebra, such as a raised to n, where n is a positive integer, constants and variables, literal coefficient and numerical coefficient, algebraic expressions, terms and polynomials, number of terms, degree of the term, and degree of the polynomial. And lastly, to evaluate algebraic expressions for given values of the variables. Before we proceed to our lesson, let us have an activity first entitled Guess Me. You must rewrite or translate the following English statements into their corresponding mathematical statements. Letter clues will be provided in each item that will help us to reveal the hidden word. After revealing the letters, arrange them to form the hidden word. 5 seconds to answer each question. Let's start. First is the sum of 9 and 7. Kindly type your answer in the comment section below. 5 seconds, go. If your answer is 9 plus 7, then you are correct. Let us see what are the corresponding letters for this given. We have the letters A and B. Let us have the second given. They write 8 minus 3 using math symbols. Type your answer below. Your 5 seconds starts now. If your answer is 8 minus 3, then you are right. The letters are E and G. Let's have the sentence. The quotient of 6 and 3 is equal to 2. Timer starts now. The answer is 6 divided by 3 equals 2. Very good. The letters are L and A. For the last one, we have 2 multiplied by 4 equals 8. 5 seconds, go. The answer is 2 times 4 equals 8. Good job. The letter is R. We have already revealed all the letters. The letters are A, B, E, G, L, A, and R. What do you think is our hidden word? Comment down your answer. Good job, students. That is algebra. Now, do you know how to translate English phrases into mathematical phrases? How about translating English sentences into mathematical sentences? On our activity, we translated the given English phrase or sentence into their corresponding mathematical phrase or sentence, like the sum of 9 and 7, which is 9 plus 7. Let us have the common words or phrases and their equivalent basic operations. In addition, we can use plus, the sum of, and increased by. For subtraction, we have minus, less, the difference of, and decreased by. The words or phrases like times, of, the product of, and multiplied by can be used in multiplication. And lastly, for division, we can use divided by, per, the quotient of, and the ratio of. For example, number 1, the sum of a number and 7. The word sum means addition. For the term a number, we can use any letter from the English alphabet to represent its unknown value. Let's say we use N to represent the number, and for 7, it is 7 itself. So we will obtain N plus 7. In example number 2, Anna and Elsa share 100 pesos. Let A be the share of Anna and E the share of Elsa. If we add their shares, the sum is 100. So, A plus E is equal to 100. Some of the English phrases and mathematical symbols they represent are the following, as shown on our screen. For example, number 3, 5 plus negative 13 minus 20, its mathematical translation is 5 plus negative 13 minus 20. Plus sign and negative sign of 13 are consecutive signs. That's why we have to put parentheses in negative 13, so we write it like this. Some of the English phrases that reverse the order of quantities in mathematical phrases are subtracted from, less than, more than, and added to. Let's have some examples of this. Example number 4, 3 times a number q subtracted from p is 25 hundredths. Since we have the word subtracted from, it means that p is the minuend from which 3q will be taken away. So we have p minus 3q is equal to 0.25. For example number 5, the square of b less than the square of a is equal to the square of c. Same thing with the previous example. A squared is the minuend and b squared is the subtrahend. Therefore, we have a squared minus b squared equals c squared. In translating mathematical statement into English statement, we have several ways. For example, a number y is equal to 4 times a number x plus the cube of 3. Or the other way is a number y equals the sum of 4 times a number x and 3 cubed. Let us now have activity number 1 entitled Let's React. We will simply translate the given English phrase or sentence into mathematical phrase or sentence. Click the heart react button or wow react button that corresponds to your answer. Again, you will be given 5 seconds to react for your answer. Number 1. 2 times a number b increased by 5. For heart, we have 2b minus 5. And for wow, we have 5 minus 2b. Your 5 seconds starts now. If your answer is hard, 2b minus 5, then you are correct. Number 2. 7 more than twice a number x for a heart is 2x plus 7 and wow is x squared plus 7. 5 seconds, go. The answer is heart, 2x plus 7. Good job. For number 3, the sum of a number y and 16 equals 23. For heart, we have 16y equals 23. And for wow, we have y plus 16 equals 23. Your timer starts now. If you drop wow, y plus 16 equals 23, then you are right. For the last one, 10 less than a number x is equal to 12. Heart is x minus 10 equals 12, and wow is 10 minus x equals 12. 5 seconds, go. The answer is heart, x minus 10 equals 12. Good job, students. In the previous lesson, it is stated that for a known value, we use variable to represent it. So what do we mean by variable? A variable is commonly a letter in the English alphabet that represents a number or quantity. Let's say we have 10 minus 8 is equal to P, and 5 plus Q is equal to 8. P and Q are the variables used. Next is the constants. Constants are quantities with fixed values. Examples of constants are 5, 0, -3, 1.3, 2 over 7, and square root of 2. In 5 plus Q equals 8, the constant terms are 5 and 8. Let us have a raised to the power of n, where a is the base. The base is the number or variable used as a factor, while n is the exponent, which shows the number of times the base is used as a factor. N is a positive integer. This expression can be read as a raised to the power of n or a raised to the nth power. Note that if there is no exponent written, it is implied that the exponent is 1. An example is 7, where the exponent is 1, but we simply write it as 7. Another is P, with an exponent of 1, and simply written as P. Let us have 5m, where 5 and m both have exponents of 1, but we simply write this as 5m. On the other hand, let us take a look at this example. For 3 raised to 3, some of the students will solve it as 3 times 3 equals 9, which is incorrect. 3 raised to 3 means to use 3 as a factor for 3 times, which is 3 times 3 times 3 is equal to 27. Another example, x raised to the power of 3 or x cubed, which is equal to x times x times x. And square root of the binomial k minus 1 is equal to quantity k minus 1 multiplied by the quantity k minus 1. Algebraic expression is any combination of constants and variables which may be separated by operations or enclosed by grouping symbols. A polynomial is an algebraic expression in which variables must have non-negative exponents. But what are some examples of polynomials? Take a look at the pool of expressions. Which of the following are polynomials and which are not? Very good. The polynomials are 3mn squared, 6xy cubed, and a over 3. And the expressions that are not considered as polynomials are 3mn raised to 1 half, 6xy raised to negative 3, and 3 over a. We should also take note of the following facts about polynomials, such as the expressions are not polynomials if the exponent of the variable is negative, the exponent of the variable is fraction, the variable is in the denominator, and lastly, the variable is inside the radical sign. The classification of polynomials is either according to the number of terms or according to its degree. The first one is the classification of polynomial according to the number of terms. First, let us define what is term. A term can be a constant like 5, a variable like y, or the product of these two like 3x. Terms are separated by the plus or minus sign, like 2y minus 4. The classification of polynomials according to the number of terms are the following. Let's say we have 5, 6y, and 3xy. These polynomials consist of one term and they are called monomials. For the next example, we have a squared b minus 1, where a squared b is the first term and negative 1 is the second term, because they are separated by a subtraction symbol. Another example is 7n plus 2. 7n is the first term and 2 is the second term, since they are separated by an addition symbol. These two examples consist of two terms, which are called binomials. Next is a cubed plus b squared plus c, where a cubed is the first term, b squared is the second term, and c is the third term, because they are separated by addition symbol. In 2xy minus x plus 4, the first term is 2xy, second term is negative x, and third term is 4, because they are separated by minus sign and plus sign. These polynomials consisting of three terms are called trinomials. A coefficient may be numerical or literal. In negative 5ab cubed, negative 5, which is the number, is called the numerical coefficient, while ab cubed is the literal coefficient. Example, negative s cubed. There is no number explicitly visible before the literal coefficient. Then we can say that it is 1. So we have negative 1s cubed, where negative 1 is the numerical coefficient and s cubed is the literal coefficient. We simply write it as negative s cubed. Next is the classification of polynomials according to degree. For the degree 0, let's say we have 100. We can write a variable on our 100. Let's say we use the variable x. So we have now 100x raised to 0, where x raised to 0 is 1. So we have 100 times 1 is equal to 100. Another is negative 3. Let us use y as our variable and raise it to 0. Since y is raised to 0, then it is equal to 1. So we have negative 3 times 1, which is equal to negative 3. Another example of degree 0 are 0.5, 3/5, 1, and negative 8. And these are examples of constant. For the degree 1, a has an exponent of 1, 2b has also an exponent of 1, and same with 1.5c, that is why it is in the degree 1. 6p plus 1 is also in the degree 1, since if we write it as 6p raised to 1 plus 1p raised to 0, the highest degree found at the first term is 1. In 8q minus 6 over 7r, since both terms have 1 as their exponent, it is also in the degree 1 and it is called linear. U squared, 4b squared, and other single variables whose exponent is 2 is in the degree 2. Another is 6w minus w squared. If we write it as 6w raised to 1 minus w squared, the highest exponent is 2. X squared minus 4x plus 4 is also in the degree 2 since the highest exponent among the terms is 2. These examples are called quadratic. Another for the degree 2 is 8uv, since the sum of the exponent of variables u and v is 2. 4s cubed, d cubed, and other single variables whose exponent is 3 is in the degree 3. X cubed minus 9 is in the degree 3 since the highest exponent is 3. Y cubed minus 2y squared plus y plus 4 is also in the degree 3 since the highest exponent among the terms is 3. These examples are called cubic. Another is 6mt squared is in the degree 3 since the sum of the exponent of m and t is 3. Let us now have activity number 2, what's my degree? Identify the degree of the given polynomials. Type your answer on the comment section below. You will be given 5 seconds to type in your answer. Number 1. The given is 5abc. What is its degree? Is it 1, 2, or 3? 5 seconds, go. The answer is 3. Very good. 5abc is also an example of a monomial. Number 2 is a plus b plus c. Does it have the degree 1, degree 2, or degree 3? Your 5 seconds starts now. If you answered 1, that's correct. This one is an example of a trinomial. Next is 2xy minus x squared y. What is its degree? 1, 2, or 3? Timer starts now. Time's up. The answer is 3. Good job. This is also an example of binomial. The last one is 5xy minus 3. Does it have the degree 1, degree 2, or degree 3? 5 seconds, go. The answer is 2. Good job, students. 5xy minus 3 is an example of binomial. Let us now proceed to our next lesson, which is evaluating algebraic expressions. There are steps that we need to consider in evaluating. To evaluate an algebraic expression, first is substitute the given value of each variable, then simplify the given by performing the indicated operations. For example, number 1, evaluate the polynomial 6x squared plus 3 when x is equal to 4. Our given polynomial is 6x squared plus 3. The operation between 6 and x squared is multiplication. Write 6, then substitute the value of x, which is 4. So we have 4 squared, then write plus 3. Write 6 times 4 squared, which is 16, then plus 3. 6 times 16 is 96, then write plus 3. 96 plus 3 is equal to 99. So our answer is 99. Example number 2. Evaluate the polynomial 5x plus 3y when x is equal to negative 2 and y is equal to 9. Given is 5x plus 3y, write 5, times the value of x, which is negative 2, write plus 3, times the value of y, which is 9. 5 multiplied by negative 2 is negative 10. Plus, the product of 3 and 9 is 27. Negative 10 plus 27 equals 17. So the answer is 17. For our third activity, what's my value? Evaluate the polynomial using the given value of each variable. Type your answer on the comment section below. You will be given 15 seconds to key in your answer. Number 1. Evaluate 5x minus y if x is equal to 3 and y is equal to 6. Your 15 seconds starts now. If your answer is 9, that's right. Number 2. Evaluate m plus 4n if m is equal to 5 and n is equal to negative 3. 15 seconds, go. times of, the answer is -7. Good job! Let us now sum up the important points in our lesson. In translating English phrase or sentence into mathematical phrase or sentence, we need to be familiar with different terms and its equivalent symbol in mathematics. In algebra, variable use the letters from the English alphabet to represent the unknown number, while constant are quantities which has a fixed value. In a raised to n, a is the base and n is the exponent, which is a positive integer. A polynomial is an algebraic expression in which variables must have non-negative exponents. A term can be a constant, a variable, or a product of these two. Term is separated by addition or subtraction symbol. Numerical coefficient is the numerical factor, while literal coefficient is the literal factor. The classification of polynomials according to the number of terms are monomial, binomial, and trinomial. The classification of polynomial according to its degree are constant, linear, quadratic, and cubic. To evaluate an algebraic expression, substitute the given value of each variable, simplify by performing the indicated operations. Let's now have the question and answer. For the first question, coming from our random viewer in the comment section, what do we call a polynomial with more than 3 terms? We simply call a polynomial with more than 3 terms as polynomial or a multinomial. For the second question from a random student, what is the importance of algebra in our life? Algebra plays an important role in our life. We are not aware that we are using algebra every day. Let's say in cooking, chef measures and prepare first the ingredients before they cook. We also use algebra in technology, health and fitness, outdoor landscaping, sports, morning routine, and many more. If you still have some questions, your respective math teachers would be glad to answer those questions on your follow-up discussion. For your home learning task, answer what's more A on page 12 and what's more try this on page 16 on your mathematics module. Let us be reminded by this saying, life is a math equation. In order to gain most, you have to know how to convert the negatives into positives. I am Miss Annilyn Estayo, your live streaming teacher. I hope you've learned a lot today. Have a blessed day, everyone.